Hello. Well, we got today a where's it gone? A little bit of a fix, daytime job. We've got this. Here we go. Let's get the back view on. Hang on. Yeah, we've got this. It's a control panel from a Ditec. A Ditec swing door operator. So let's go on to down. Yeah, so here it is. Hang on, where's my picture? Yeah, so basically this is a swing door controller. I'll tell you what the model is. Hang on. It's type 196 Entrematic group. Entrematic.com. 230 volts. Year 2016. So basically what happens with these is capacitors. The capacitors are too close to the voltage of the bridge rectifier after it's been rectified. So what happens is I'll just take the screws off. They get bloated. There's about 6 or 8 capacitors that get bloated. So what we have to do is just take the board apart, unsolder it to get to it, replace the capacitors. Normally fixes it. Okay, so we're giving it a go. I'm supposed to be at work at the minute, so this is for the work. So that's fine. This is for the work. Right, I've got to undo these things here. I should use a hex nut really. What have I got here? It's a bit ad hoc, sorry about that. What have we got? Ain't got much in the way of pliers up here. That's a bad thing straight away, isn't it? Hang on. We're off to a good start as per usual. I normally do this. Get off to a brilliant start. Tools. Hold on a second. Oh, knocking into everything. Tools. Right. Okay, we're back. We've got a little socket thing here, so hopefully we can do it right. Oh, it hasn't got one for that size. Can you believe that, eh? Oh, is that it? That's the one. It's alright, they're in the wrong slot. There you go. We've got one of these little T-bars to undo it. That was tight. There was no way I was going to undo that one with pliers. So it's Monday morning, and I couldn't be bothered to do this in my own time, so I thought I'll do it Monday morning in the works time. Alright, okay, so we've got that undone. Next is to undo the flat screwdriver now. Better go away again, get a screwdriver. Right, here we go. Yeah, we've got to take these off. You take two X nuts off, and this other one. Let's get the desoldering pump on ready. Get it warmed up. I'm going to use the Dura tool desoldering station to take it apart. Yeah, so these capacitors are bloated here, all these. Can you see them? Well, you can see them. Let's get you on the microscope. The microscope cam. Right, just going to go hands-free with this at the minute. Let's get you a bit of an angle on. Yeah, can you see? Can you see the bloated? See the bloated capacitors? There you are. Let's back it off a minute. Yeah, bottom left-hand corner. Can see the capacitors. They're all bloated. Look, see. And they're bloated because look, if you look at the side of them, they're 35 volt. 35 volt microfarads. It's 35 volt. I think they're 100 microfarads. 20 microfarad, 220 microfarads. 35 volt. And you've got a bridge rectifier. Got your bridge rectifier there. Hang on, let's back it off a bit. Yeah, see a big bridge rectifier there. Anyway, let's get rid of that one a minute. Yeah, bridge rectifier is 24. There's 24 volts AC coming into the bridge rectifier. When it comes out, it's about 37 to 38 volts. So it's already over the voltage of these reservoir capacitors, which is 35 volts. So they'll last a while, but they're not gonna last indefinitely. So after a few years, what happens is they just start bloating and leaking. So anyway. Yeah, so that's the reason they blow, and I've done a few of these in the past. The alternate used to be able to get new control panels. I don't think they make this model anymore, hence having to fix it instead, unless you want to change the whole operator. Right, my desoldering gun is up to temperature now, so I've got the desoldering gun on the go. This and this here is these the transformer pins that stick through. You can't take this off until you've unsoldered them. So you can't get to these because they're way underneath there. They're behind this bracket and that, so you can't get to them to desolder them. I've just lost one of the spacers. What's happened to that? Dropped a spacer. There it is. We got it. Yeah, just a warning, there are some spacers. These little spacers, and they fit under there. See that? So once you take the screws out, they just drop out. So you got to remember to put them back. And there's some more spacers in here as well. So here we go. What I'll do is just stick a soldering iron on. I'll just let's wet my sponge. Get the sponge wet. There's a lot of water there, actually. Oh well. Right. Yeah, I got the soldering station. It's a Precision Gold A55 KJ. We'll get that up to scratch. What I'll do is I'll put a bit of solder, bit of fresh solder on these two joints, and the reason I'm doing that is just to make it easy to desolder. Okay, here we go. So I'm just going to solder. I've got no mains on this, by the way. I'm not even going to plug it in, because it's pretty much a surefire thing that changing the capacitors will bring it back to life. So there's really no point. I've done a few and I've never had any fail yet. Okay, right, we're going to make it easy today. We're going to desolder it with a tool. There we go. I'm just going to hold it on an angle. If I can get it. Oh, that's nice. Okay, looks good. I'll just see if I've managed to free it up. Nearly. That one is. This one ain't. This one needs a bit more persuasion. Okay, hopefully that's done the trick. Yeah, as you can see, it's trying to come away already. Lovely. Right, here we go then. Let's just take that off and lie it down. Yeah, this we've got this spacer PCB. There's a couple of these small spacers on top of there and there. They're slightly shorter than the other ones. So that's away, and the main transformer. Just got your mains in there. You've got a choke or suppressor, and there's a. I think you can just see it in there. Can you see it down there? No, it's hard to see. There's transient voltage spike suppressor and a couple of fuses, a fuse on it. Okay, so put that to one side a minute. And here we go, we've got to unsolder these now, so we can get rid of this piece of plastic. So all the capacitors just here. The ones that aren't bloated, it's really not worth changing them, because they'll be fine. It's just these ones here, they've put them all, if you look at them, they're all on the same rail coming out. And they're all bloated at the same rate, those. So I'm going to take them out now. Easier said than done. Now I can either try and desolder them. Just bend that out of the way. So let's try the solder. Tell you what, we'll freshen up the solder again. We use the same trick as we did last time. Here we go. So we're going to just freshen up the solder. There's each one of these capacitors connected to the ground plane, which is 0 volts. So it'll make it a little more difficult to get out. Yeah, it's not going to be easy. Hence, that's why I didn't want to waste my time the weekend doing it. And I've done a bit more on my CNC packed up. I've got a 6040, Chinese 6040 rotor. There's 3 stepper motors. The Z-axis started playing up. I was just thinking of putting some flux on this, but I'll keep going this way anyway. Yeah, I was warned about the Chinese cable that came with it. A lot of people recabled them when they were brand new. I didn't recable mine. I had it since about 2011. Anyway, luckily enough, it was only the cable. I lost the yellow core in the cable that feeds from the Z stepper motor output to the stepper motor, the Z stepper motor. Oh, is that part of that? Yeah, that's part of that. So I used another piece of cable and threaded it through with the old one, taped it to the old one, and threaded it through. The whole thing needs recabling really, if that's what's going to happen. Basically I was pressing down and it would go up, I was pressing up and it would go down. So I've just found part of a component. Oh, I must have took that off something. Right. So they're all there's one more there I've missed. There you go. That's it there, yeah. Yeah, one more here. These are just reservoir capacitors. Instead of using bigger capacitor, they've just used loads of small ones. Not sure why they do that. Anyway, let's see if we can desolder these capacitors now. I'm going to do edgeways on. I'm going to hold on to the capacitor as I do it. And let's get the ground plane done first. Just wobble it around and has it worked? Not sure. We'll test the capacitance on these just to see how bad they are. This doesn't really work. This isn't. It's difficult. Oh, it's come out, yeah. Well, there's the first one. You can see all the leaky capacitor. Yeah. We'll measure them in a minute. Right, let's get the rest out. At least they're coming out. So the trick is now I'll do the plus pin that's not on the ground plane first. Just bend the capacitor back, and then when you get to the one with the ground plane, oh, it dropped out pretty well. So they're coming out slowly. Yeah, they're coming out pretty well. It's not too bad. Sometimes these double-sided ones can be a pain. It's awkward sometimes. Yeah, it's a bit fiddly to get you. Yeah, got it out. It's fiddly sometimes. We've got to get these holes cleared up really. Right, keep going. There's quite a few. They're all in parallel, I think. So really, you could just put a bigger one in if you wanted. So yeah, we've got no thrills today, just live. It's live stream, no editing. I've got to make some with some editing at some point, but right, I'll see the other one. Okay, how many more we got left? 2 more to go. 2 more to go. Hopefully, if the holes are clear, should be a quick repair this. It helps with this tool. Yeah, I've had to do this at home because we haven't got facilities at work to do this kind of work. Normally buy a new panel, put it in, but it's a case of repairing this instead of basically the customer would have to have a complete new system put in otherwise. Right, that's the last of them, I believe. Yeah, not going to bother changing these two, they look fine. And because these aren't on the same rail as it comes out the bridge rectifier, they're not on the same rail. So this is the voltage that comes out the bridge rectifier, then it goes through, gets regulated down to 24 volts after. So, right, just tidy the end up. I think what they do is, I'm not sure. I think we have to. Let me just shine it. See if I can see a light through it. Right, and believe it or not, they're all clear. Let's see if I can show you that on here. I don't know if I can show you that. How can I show you that? Shine a light through it, maybe. Yeah. Let's see if I can shine a light through it. Right, I've got a light here. Yeah, I can't really show you that. It's difficult to see. What about the rear camera? Can we do it off the rear camera? Right, rear camera. Light shining through. Can you see that? I don't know. Not really. Oh yeah. Anyway, that's done. Right, so our next job is to find the capacitors. Where are they? Let's have a look. What did I do with them? Good question. $200 microfarads. So what have I got in them? There's a bag of them somewhere. Right. Give you a top-down view. Back in a minute when I find these capacitors. We're back, yeah, we're back. Whew, it's warm, innit? God. Excuse me. Right, let's try and find some of these. Hopefully we've got some left. 220 mic, 50 volts DC. Yeah. The ones that come out of it, 35 volts. We've gone slightly higher. There's the RS ones. Slightly bigger body, but it's still okay. It fits in the hole and the pin. So I'm gonna need. I've got 6 there. 4, 5. We need some more. That's maybe a problem. Maybe a problem there, ran out. I've used a lot of these over the years. So, right, it's looking a bit sick at the minute. That may be the last of them. Well, we're okay, we got some. We got some. We got plenty left. Okay, here we are then. I don't need the desoldering tool anymore, I'm going to switch that off. Okay, right, just a matter of interest, let's just have a look at the capacitance on some of these failed ones. Stick it on capacitance check. Nanofarads. Right, I'm all tangled up here. Good God. Cables will get tangled up, don't they? Right, so this is how you fix a Ditec transit UE control panel. Right, let's do some tests. So we've got nanofarads there. Excuse the light shining. So there's your negative. Let's see, these are supposed to be 200 microfarads. Let's see what we got. Here we go. What we got? Anything? She needs crocodile clips really. Well, I can't even measure that one. That's how far that one's gone. Let's try another one. Let's just hold them like that. Yeah, because they're bloated, they're spinning around. Not even measuring that. Right, let's get a new one out and see what that one says. Right, okay, let's get a new one out. Let's see what we got on the new one. 218 microfarads, 219. So as you can see, these things are just not doing anything at all. What does it get there? Does it get anything there? No, that's what's the matter with them. Totally dried out and knackered. I'm not going to bother testing anymore, they're all the same. Right, so that's what your problem is. There's no reservoir capacitor. They're basically non-existent, and they aren't shorted out, but they're just not providing any smoothing at all on the AC bridge rectification. Right, let's just have a quick look at the board. Do I need to clean it up at all? It doesn't look too bad actually. I could clean it up if I know cotton. Oh, just a lot of stuff collapsed. Anyway, yeah, this board's clean enough. I'm not going to bother to touch it up. In fact, there's a lot of stuff down here from when they manufacture it. A lot of flux. That's nothing to do with what I'm doing. Right, let's put them in. Here we go. So I'm not going to tell you which way around they go. You should know. Plus, there you go. So I drop that into there. Just spread them around. Let's get some more out. So what am I doing at the minute? What are we up to? Right, over there, doing a silly thing, wasting my time creating a. Make sure they're all the same value. A business brochure holder. I milled that out and my ZX has started playing up on me. So I had to fix that last night. So that was the end of my work for that night. This morning, just finalising the 5mm polycarbonate enclosure for the product. Designs ready for milling out. I tried to make it out of 4.5mm plastic, and it came out with too much processing to tidy it up after. So abandoned that idea. Didn't want to spend too long filing it and sanding it. Just want the milling machine to do all the work basically. So decided to make it, hopefully the polycarbonate will be harder material to mill, as in it won't fray up so much. There's less work to tidy it up after. I'm milling them out at the minute instead of so milling it out instead of doing laser cutting. The reason is I have to create pockets or mill halfway through it. I don't know really how to do that on my laser. I got one of these Chinese laser 40-watt laser machines. So we've got to get that on the go at some point. Last one. Okay. Yeah, so we're all good there. Let's just solder a leg, put them down and solder one of the legs. Okay, I'm going to solder one leg. And then I'll push it in and hold it. Solder the leg, the positive leg, it's easier. Just hold it in situ, and then I'll press it down as I solder it. I've soldered the wrong side of that one, anyway. Okay, that's them all. They're all sort of random all over the place. So what I'll do, just press them in as I warm the solder up. That's okay. Next one. Oh, I haven't actually soldered that one. Yeah, it's a bit of a finicky job because they're so close together. But it doesn't take too long, as you can see. Look, if you've got the right tool like this. Now you have to sort of have your hands everywhere. Hand holding it still, your thumb pushing the capacitor flush with the surface. Okay, so they're all okay. Look at that. Not bad, not bad. Okay, so I'll just go and solder the backs now, and hopefully that will be done. These are the ground planes. I'll leave the soldering on a little bit longer. Very awkward. Okay, let's do a bit more of that. Have we finished? I don't know. It's easy to check this out because they're all on the same round plane, you know, all on the same, they're paralleled up, so it's dead easy to check if there's any shorts before we plug it back in. Okay, that looks okay. Just double check the pluses are all around the right way. All the long ones are on. Yeah, all the long ones are in the isolated from the ground plane, yeah. Okay, let's cut. Let's cut the stems off. I always have to keep these. Make sure I don't drop them because I don't want to stand on them. Buggers. Yeah, I'm doing a working on a. I've got a sensor. It's a carriage, but it fits as a collar onto my UPass system. It's got 5 neopixel LEDs on it. It's got a non-touch thermopile, and it's got a LiDAR distance sensor. I've noticed with it's going to be a temperature monitor. It's going to be that records your temperature. Now, I found with these temperature monitors, a lot depends on how far you are from the person when you're taking the temperature. It varies. So what I'm going to do is use the LiDAR to give you an indication when you're the right distance away. Right, let's do a little continuity check, make sure we haven't got any shorts. We'll have a quick look under the microscope as well, see what the state of affairs is. Right, so we've got our, let's just, we'll put one on the ground plane and one on the plus. So that looks okay. All the ground planes are connected, yeah. And there's no, all the pluses are connected, supposedly. Why isn't that one connected? Oh. I thought they were all connected, maybe I was wrong. That is weird, isn't it? Yeah, I thought they were all connected in parallel, but they're not actually. Are any of these connected in parallel? Them two are. So these last two are not directly connected to the rest on the plus. So, oh well. Right. They look okay anyway. So what I've got to do next is put it back together. Yeah, so this LiDAR, what's it going to do? Do I need to tidy it up? Let's give you a visual on it. Let's give you an inspection on it. Why not? Well, I can find it. Where is it? I'm going to have to increase this size. Microscope. Right, let's have a look at microscope down, view. Let's have a look. Let's give it some more brightness. There we go. Sorry about the handheld, this is probably a messy thing. Right, let's have a look. Yeah, sorry about the shaky hand footage. So there's that two. They do look horrible when you get close up. Not too bad. You can see there's quite a space around the plus side of that. And this one over here, yeah, looks okay. Right, so that's that. Right. Let's get you back to the top down view. And we'll put it back together. I'll switch my soldering. Oh no, I need the soldering on for a bit longer. Alright. So I've got to solder. I've got to put this back together. I've got to solder these two pins here, so let's line this back up. And this is where you've got to be careful you put all your bits back. Now that glue tells me where it used to go to, so I think, did it? Or was it that way round? No, that was the way round. Oh yeah, that's it. Yeah, so right, so you've got to drop your two short ones in here. Two short spaces. Not sure where they go, so let's have a look. Right. That's going to go like that. So two short spaces here and here. Get these lined up with these holes, and it's a bit awkward because you want to tell you what to do. I'll put that on there first. That'll help it a bit. Now you've got to somehow slot this underneath there. And at the same time, get it over these two pins that are sticking up. So, not very easy. Yeah. And you've got to somehow get those. Make sure you haven't lost the position. Okay. And you don't do any soldering at this point, because you've got to get your spacers in. Ready. I think I can get a screw in there actually. Try and work work out which. I can't remember which way the lid went now. So that goes on there. Yeah. So these go in here. I'm not going to tighten them up at this point. Just going to start the thread. Yeah. And that one there. Start the thread. Okay, and we've got these hex pieces there in the back now. Last spacer. It's an awkward one to get to, this last spacer. It's right in there, look. And you got to get your spacer in there. Just put your hex through at the same time. Start your thread. Yeah, that's okay. So that also grounds through to your main equipment. Right, so tighten it up. Here we go. I haven't got much space. I'm knocking the camera, sorry about that. Not too tight, you don't have to go crazy. That's good. Okay. Now these, just the screws. Okay, so they've used a bit of PCB there, 2 bits of piece of PCB to separate the mains from the low voltage, which is a good idea. It's hot melt in place, but I don't need to do that. It's held by the screws anyway. So. Right, okay, we're pretty much there. Got to solder these two. That's the next job. Let's solder them up now. It's a bit fuzzy for you. Let me turn this other camera off. Okay, here we go. That's the one. Now the next one. And that's it. Job done. That'll do. And don't bother clipping them off because that's handy to get to for next time. So switch off the power supply. Just put the lid back on. I could power it up, but the trouble is there's lots of limits and stuff here for the open and close limits, so you probably won't want to do a lot anyway. So I mean, it's best just to try. I'll just try it. Normally you would have a motor ready to try it, but we know there's no short on it. I can do one final check with a meter. Just make sure there's no short across the bridge rectifier. There's your plus and your minus. Yeah, there's nothing there. There's your AC comes in there. That's your AC. So your AC will come in there in the middle. And it come out from one of these. Yeah, that's the winding there, and the other one is there. So there's no fuse. There's no fuse from out the AC of the transformer to the bridge rectifier, and then it comes straight out of the bridge rectifier, straight out of there, out the plus of that, into the plus of your. Let's put that onto the plus. Yeah, straight out the bridge rectifier the plus to those plus the capacitors, so you're going to get these 35 volt capacitors. These 35 volt capacitors, they ain't gonna never designed to last long, because there's 37 to 38, 39 volts coming out after the regulator, which is going to burn those out. So we've got 50 volt versions in now, so that should last a whole lot better. Right, stick the lid back on and put down the. We've got a star washer just to give it the ground, and we're almost ready to be done here. So anyway, that's the Ditec Transit UE, or a Entrematic 196 control panel repair. Bad design. Shouldn't, as far as I'm concerned, it should never have been allowed to be released. It just goes to show you can buy stuff that's really, it's going to last a few years and then it's going to break down, and you're going to end up wanting a new motor control panel, stroke control panel. Anyway, that's all we got for today. Let's put some. No, won't put nothing on it. Won't play the tune. Okay, stop streaming. Goodbye. Like and subscribe if you want to. Bye bye.